I'm going to talk about HyperCLOVA, which has large-scale generic language model. Thank you for coming. I'm going to introduce myself. My name is Toshinori Sato. I am a software engineer in natural language processing and information retrieval. Before, I was responsible for Japanese NLU system development. Since 2021, I am a manager of NLP development team and also looking at the Japanese language version of the HyperCLOVA. Privately, I lead OSS project LINedevday. In this presentation, I will present accomplishments of NLP development team and the former members' contribution on behalf of my team. Thank you. And first of all, please pay attention. This session is mainly for engineers who are interested in natural language processing, so a part of it is for NLP professionals. NLP means natural language processing, and it will appear many times in this session. We will not talk about language model creation nor details of adjusting method. Those are written in the NAVER's thesis published in EMNLP 2021, and please refer the Korean version of the case. This session takes 40 minutes. Please enjoy your coffee and listen. Now, I will show you the screenshot of my recent chat. The other side is Mr. Color Pencil. Hello. Hello. Which color are you? I am red. Which color is more important than you? Well, it's blue. Why is that? Well, blue ocean, blue sky are beautiful. This is the result of chat with dialogue system using HyperCLOVA. HyperCLOVA is a name of the system that contains a large-scale generic language model and a user interface to check the output. LINE and NAVER jointly operate HyperCLOVA system. About 1 year ago, LINE and NAVER announced that we were going to develop a Japanese language model, so I will give you the update of that project and the related information. Well, the chat I have just shown you. These red pencil are the exact output of the auto-generated text by HyperCLOVA. Without explanation, you understand that you cannot talk with the Mr. Color Pencil in reality, but this kind of a dialogue is called as role play. HyperCLOVA becomes the color pencil character and have smooth and correct reactions. How these responses are coming back. Now I will show you the application which picks up a voice from microphone and send responses back through speaker. So user says whatever he wants to say. Hello. This voice is input to the client application as voice sound. By using speech recognition technology, client application converts sound into text and sends this text to dialogue application. Dialogue application generates a query for HyperCLOVA. Depending upon the situation, HyperCLOVA uses a large-scale generic language model or knowledge-based search depending on the query, and it outputs some response. Dialogue apply creates responses text based on the HyperCLOVA output. Client application makes this output into voice data by speech synthesis processing and output it from speaker. Long time no see you, like this. And at the deepest level of this flow, there is a large-scale generic language model, which is today's topic. So far, I explained what the HyperCLOVA is. Here are things that we present. After this, I'm going to talk about the details of the HyperCLOVA and introduce application development by prompting. Then, HyperCLOVA's LM subjective evaluation at dialogue task and the auto-evaluation result, question and answer task. In the end, I will present how we are applying these to dialogue system. Here are the details of the HyperCLOVA. Here are basic knowledge of a language model. Language model stands for language LM stands for language model. And language model in NLP is a statistical language model. This model returns a probability value for word string. Probability of "it's fine today" is greater than the one of "fine is today." This is called the probability of appearance. This shows the possibility of a word string at corpus, which was used when model was created. Like many famous large-scale language model, HyperCLOVA is unsupervised autoregressive language model, so it can calculate probability distribution, and when sample is given, it does maximum likelihood estimation of parameters, and based on the text up to now, it can generate the future text. Language model is corpus, which is used to build models, and this is very important, so I would like to tell you. LINE does not use customized messages, talkroom chat, any data related to LINE conversation service at all. And we are trying hard so that this corpus can be used generally inside and outside of the company while paying attention to all the right methods. So let me tell you LINE LM corpus that we are building with such a policy. This is used to build a HyperCLOVA language model. This corpus is based upon the corpus which was made to build the BERT model after 2019. Unpublished personal information which can be easily extracted from corpus is built is deleted, and purchase and the use of the external content is done after solving all rights-related issues. And we are trying to cover necessary information to learn Japanese language phenomena. At the same time, we utilize the data for line search without infringing the rights. LINE LM corpus has 10 billion samples, about 1.5 terabyte, 500 billion token. This corpus gets updated every month, and its size and quality are improving. You can extract the data from each category from corpus, but we are focusing to create one chunk for generic language model. Before HyperCLOVA, system development using NLP was to build a small-scale generic language model, such as a BERT or machine learning model, to each task. In HyperCLOVA, we do not want to build a new model at every task changes. Rather, we use one big model. LINE's computing resources are finite, so rather than taking time for each task fine-tuning, we want to spend more time to build a new generic model. Regarding this new model creation, currently 82 billion model of Japanese are proceeding. Model less than 82, there are prototypes and evaluation going on, and various tuning and experiments are going on. As for Korean, as announced in NAVER AI Now in May and EMLLP 2021, 204 billion model is being built. As for Japanese model, more than 204 billion models will be used in 2022. These models are in the model layer in the HyperCLOVA architecture. HyperCLOVA handles the various size and types of the models. Task-specified model, fine-tuned, small size, learned model, in order to establish know-how to enhance the performance. Experiments and evaluations are done repeatedly. I will talk about those in later slides. Now I will talk about prompting and its application development. There are two ways to adapt one learned generic language model to the task. First one is fine-tuning. Task data set is prepared and we do supervised learning. The good thing about this method is that the supervisor's data is used, so tasks' benchmark results are very good. But shorthand is that it needs to learn each task, and the model's generalization performance may be impacted. In another method, task explanation or some solved task model are given as context. It is called few shot, one shot, or zero shot. It may not achieve performance as a state-of-the-art model, but you only need to prepare very short instruction or task samples, and it can achieve a creation certain performances, and this is confirmed. Now let's take a look at the terms for this few-shot prompt creation. I write playground here. In case of HyperCLOVA, it is a HyperCLOVA Studio web application like this. This screen and framework are the same thing. And Playground has parameters and UI parts that specify options, but we ignore all of them and focus on the text field. In this field, we text the input and output, both. Prompting is called as a prompt engineering or prompt programming, depending on how it's created. In case of auto generation, it is called as a prompt tuning or p-tuning. Since this is a new area, so new methods and a new naming are coming up every day. Prompt has a region where tasks can be written. Result of estimation is made backside of this outline. Title is, of course, important. You can enter any word string, but finding more proper title changes the result, and it is confirmed. It is difficult to find the location to put the necessary information, but if you put them in the field next to the title, it will be easy for implementation. If number of shots in the sample changes, prompt naming will change. I already explained that when shot number is 0, 0 shot, 1, 1 shot, and multiple shots, few shot. So this is an example of the title and the few shot. Title says execute 4 arithmetical operations, and we have 2 samples. So this is the way of calculation. So this is a few shot prompt. Query is written in the same format of each shot in the sample, but the end part is deleted. And at the estimation, backside text is output. And you can get output finally, but sometimes you want to estimate continuously by going down like this. And what should we do? We have to put the output somewhere. So in order to explain, I just divided them, but everything is expressed as text. So last time output can be included as one of the shots. So when we have the data, by using 2 shots, write Haiku example with the title. It's like this, and the query. By deleting the last part, it will be executed like this. If this output is not what you really want, you can edit it by manual. In large-scale generic language model environment, particularly at the early stage of development, task-specific prompt is created, and it contains a few shots, which is the result of prompting. By this, you can adjust language model output and get the result very quickly. If you are not satisfied by that result, you think about fine-tuning or development of task-specific element technology. There is a reason not to do the fine-tuning or deep development from the beginning. Calculator necessary to build a model and the calculator necessary for fine-tuning are having the same scale. In HyperCLOVA scale, we need calculation resources in order of magnitude bigger. I will show you the demonstration, explanation about the product that will be created. On product packages, we see product explanation, and that is written by salespeople. In this demo, we adjust the parameters of HyperCLOVA Studio and it tries to create some appealing explanation. So, we input the title to HyperCLOVA Studio. And the product name, overview, and explanation are given as sample. It's a one-shot prompt. And then as a query, product name and overview input. It's a crab meat powder and corn powder. So let's create. One text is created. But this is too short and not appealing. So we adjust the temperature parameter, raise random creation probability, and execute. Now longer sentence is created. There is no chemical seasoning. And then I created on and on. And we wanted to start with the slightly sour. So I decided to create from behind. And the repetition penalty is lowered. And keep on creating. Now we have an appealing text such as when you put it in your mouth, it crumbles into pieces. It's appealing text. So this is fine. And I finish. So this is a demonstration of a product description. So we use a one shot in that demonstration. So title, product name, overview, and explanation. And based upon this, in the query, we put the product name and the overview. And as a prefix, put the prefix and the word string that needs to be following. And creation is done and we obtain the output. In this case, we increased the temperature and adjusted the repetition penalty so that we obtain the text which closer to what we wanted. So in the current text creation, we need these adjustments. From now on, I want to evaluate the text of HyperCLOVA. So we looked at the Japanese language model to do this evaluation. First of all, we do the subjective evaluation to look at the performance of this model. So we apply models of 6.7 billion, 13 billion, and 39 billion to 4 tasks. To confirm, these 4 tasks are all dialogue tasks. 1, does it understand the meaning of the word? 2, is it following the change of topics? 3, when user talks a certain topic, can it respond as expected? 4, can it do the free conversation smoothly? So we asked 5 people to do this evaluation, and all were done on the program. So here I want to show the result.
Let me explain evaluation criteria for these tasks. Number 1, was it a natural reaction? Number 2, did it stay on topic, not as a whole conversation, but for each of the response? Number 3, did it provide a topic for each of the response? Number 4, did it achieve a goal? For example, for task number 1, did it understand the meaning of the words? Whether this goal is achieved or not is the criteria. Task number 1 is very simple, evaluating whether it understands vocabulary. For example, ask HyperCLOVA, what is elementary school? How do you feel about elementary school? As a level 1 question, ask what? And as a level 2 question, ask how. We make up a set of elementary vocabulary that all elementary school kids would understand and secondary vocabulary junior high school level. and ask questions based on these sets. This is the result of evaluation. As for evaluation, score 1 for correct answer, 0 for unclear answer, and -1 for wrong answer. Score for all the correct answers are aggregated. So let's look at the result. In order of looking at 6.7 billion, 13 billion, 39 billion, 39 billion was overwhelmingly good. But in natural response and following a topic, it was 98%. On the other hand, providing a topic is 0. As for achievement of goals, that is understanding meaning and appropriate response, as the level goes up, the achievement also increased. Now, let's look at tracking different multiple topics. In this case, after a conversation about topic A, the topic should be transferred to topic B within 10 round trips so that we can check it follows the changed topic. For example, topic A is about COVID-19 and it is switched to inbound within 10 round trips of conversation. This shows the result. The result shows something interesting. In natural response, the figure for 13 billion slightly decreased. In addition, results in following a topic and achievement of goals were not satisfactory either. We have not analyzed in the details yet, but right now we can say that when the level goes up to 39 billion, the performance is dramatically improved. So we saw some issues in 13 billion and the issue was resolved in 39 billion. Sudden resolution of some issues as parameters rise can be often observed in large-scale language model. Looking at each result, except providing a topic, the score is 90%, so we can say there are no problems. The third evaluation criteria is reacting to user sentiment on a topic. Column sentiment A shows positive response, and sentiment B is a negative response by a user. The task is to evaluate whether the model can respond in accordance with the sentiment of the user. To be more specific, when the user has a positive sentiment like the ones in A to a topic, agreement is encouraged to the model, and in the case of B, a controlled response like, "Is it so?" is appreciated, not giving a quick agreement. So, how is the result? When the user sentiment is A, positive, accuracy was 90% and very high, although providing a topic is always poor. On the other hand, when the user sentiment is negative, we didn't say any issues in 39 billion model for natural response and following a topic, but as for achievement of goals, that is avoiding a quick agreement, the score is almost half. We think that it requires thorough consideration. The last evaluation is about free chatting. For this point, as long as the user can enjoy conversation, the result is perfect. We didn't say any problems here. Natural response and following a topic showed a very good results. However, curiously, the results for 13 billion was lower than 6.7 billion. This requires further analysis. Repeated experiments and modeling may change the results. So, let's look at the overall results for 39 billion model. One of the issues is about number 1, basic understanding of basic vocabulary shows only 80% in achievement of goals. That means there are still many things that model doesn't understand from the eyes of people. It requires integration with knowledge search, deploying knowledge base. As for response to negative sentiment, we think further deep analysis, including filtering based on text, consensus recognition will be required. For all the parameters, the result in providing topic is very poor. We think this requires some functional development to improve this area. One of the R&D goals of LINE's natural language processing team is to achieve high-quality, secure output from systems equipped with the language models that we have built. In the future, we hope to provide the same level of safe output to LINE customers for their research and development. However, we have not yet achieved the application of HyperCLOVA to the products used by our customers. This is because there are many issues we need to consider or overcome before we deliver to our customers. One of the challenges is the difficulty of the Japanese language itself, which makes it costly to maintain the quality of the corpus and the text generated. Japanese is extremely difficult to learn compared to various other languages. Japanese speakers use various types of characters such as hiragana, katakana, kanji, and romaji to create a single sentence. Often the same word is written differently when it is used multiple times. It is said that Japanese has an essential daily vocabulary of over 8,000 words, which is much larger than other languages. Japanese has a wide variety of notations and homonyms, and without a broad understanding of these, daily conversation is impossible. You also need to switch the vocabulary and you use depending on the situation and position of the other person. Furthermore, it is known that the Japanese language has many dialects, and even though the meaning is the same, we have different combination of words throughout Japan. Finally, because Japanese speakers tend to omit subjects and objects in documents, even machines need to take into account the omission of words in a sentence when interpreting its meaning. These are all very difficult, so LINE has been working on these difficulties. In fact, there are some research institutes and companies that have been working on these fundamental issues for a long time, and we will continue to collaborate with them. We will provide more information on this as soon as we have some results. Another issue is related to the difficulty of text generation. The first is the possibility that the generated text may be risky. Business in the corpus and the notation of the corpus need to be improved, and the truthness and security of the output text needs to be ensured. This is an issue that has often come up in the past when many companies create new articles, advertisements, and other texts that can be fully stuffed. HyperCLOVA can generate very smooth text and has a certain amount of potential to assist human creativity, so we are currently facing this challenge. The next step is to implement AI ethics. It is highly desirable that the generated text output by the AI meets the same ethical standards as many of our customers. In order to do so, we need to make sure that the corpus data during model building and the queries during estimation also meet ethical standards. We know that we need to consider various ethical aspects in addition to those listed here, such as whether the situation is uncomfortable for humans to view, whether it makes them feel unquotable, and whether it is overly sexual or offensive. LINE's AI company has multiple teams going on about it, with teams that are researching and developing both methods that implement AI ethics with multiple approaches and also methods that attack those AI ethics. Another is the realization of automatic evaluation. There are metrics such as accuracy, consistency, and goal achievement of the generated text that will need to be measured when applying HyperCLOVA to various tasks in the future. It doesn't correlate well with perplexity, which is easy to evaluate automatically. Sometimes it is necessary to adjust the semantic aspect of the context, but how can we automate such indicators? Many researchers are struggling with this problem, and LINE is now working on it. We aim to publish the result of the LINE NLP team's work on each of these issues in the form of academic publication and system implementations. LINE is in the process of conducting an exhaustive automatic evaluation of various intellectual aspects. Next, I will give you a summary of certain results of the QA tasks using JP model. The tasks in this presentation is what we call the RCQA possible tasks. This task is a version of the original RCQA tasks with the unanswerable cases removed. HyperCLOVA can generate text, but it can't fill in holes. Therefore, somehow the wrong text is output on the backside. The judgment about the answer is based on whether the correct answer is contained in a part of the output result or not. And the few shot is randomly generated from the dev data of the dataset. The maximum number is set to 4. This is because we found out in advance that the maximum number of few shots is limited to 4. Please look at this result. Please note that 39 model including context shows the best performance in use of 4 shot. This is not an original RCQA task, but RCQA only task, but the validity was 89.83%, which is very high. In order to check the difficulty of this problem, we let them solve only with language model removing context, which achieved 80.51%. We confirmed whether the same level of performance can be achieved with BERT. The result of HyperCLOVA is slightly different since we re-experiment at the same timing with BERT in order to set the same experiment conditions, but both results were the best scores they can achieve. A part of LINE LM corpus was used for BERT large model. As you can see from this result, BERT with fine-tuning achieved better performance than the model without HyperCLOVA fine-tuning. Here we can see even BERT can achieve better performance by fine-tuning large game model and specifying in certain areas. On the other hand, HyperCLOVA can exceed the performance of BERT just by prompting and parameter search, not with fine-tuning. Lastly, I'd like to show you a demonstration of dialogue system. With HyperCLOVA, I'm going to talk to Ms. Dishwasher. Please have a look. First, we need to create a talk room. Since I want to talk with Ms. Dishwasher, I created a username Dishwasher. I say, hello, I really wanted to talk with you, with a rather cold response like, I see. So I asked, you look convenient. How? Then the answer was more reliable, like, I'll take care of everything. Asking any tips, then the reply is, dirty dishes and clean dishes should be separated. To the question of any other tips, Dishwasher gave back several answers including, when you put leftover in me, it will make me dirty, which is a right reply, talking as a dishwasher. When I asked, is the water hot? Even though then, thoughtful answer maybe came back, showing me a kinder side. In the end, I got a little distracted and said, I'll be careful. Then the dialogue was suddenly terminated with, okay, goodbye. That was how conversation with Dishwasher went on using HyperCLOVA Friends. Like I mentioned at the beginning, the demo shows HyperCLOVA can role-play to some extent. It was very good that the response was smooth with no character set for each, and understanding was good. While the reply was rather cold at the beginning and the same in the end. Some might prefer this response, but we cannot assume the type of users in advance. So it seems we need to manage persona to stabilize response when we create a bot like this. The fact that it is capable of this response means that it will be somewhat affected by data bias. We would like to extract its positive effects only. Furthermore, what was said was vague in places. It was not an issue in this case, but maybe we should verify in advance whether the reply will be all right or not when the model is delivered to customers. That's all about issues, and in general, we think results were good. We see some possibilities in HyperCLOVA and other language models. Are they really necessary? We need this if the budget allows. History of language processing is strongly linked to the development of AI-related technology, quickly incorporating emerging technologies. Large-scale language model is definitely a turning point for NLP. At this turning point, we believe that we should take a side of creating and using those models. Maybe we can communicate with the result of this choice in the form of the latest information of HyperCLOVA. Lastly, let me touch on the relationship between LINE's future and NLP. It's been 10 years since LINE was publicized. The second most common question we get from NLP expert is there anything left to do for you? I clearly say this is wrong. Please have a look at main issues related to HyperCLOVA. Still, there are many left. There is no way we can finish all these tomorrow. Furthermore, LINE operates music and gourmet, blogs, lives, and so on. More than 50 brand services and numerous services related to these. We are still in a situation where we can make essential improvements in those services by NLP technology. At LINE, you can research and develop NLP technology in various granularity. Please join LINE and take the challenge. Please email the recruitment office in LINE first, but we are going to create an opportunity to learn about current LINE NLP easily. This is mini hands-on for HyperCLOVA. Mini hands-on for HyperCLOVA Studio and HyperCLOVA API will be held during 2021. Although the capacity is limited, please wait for the information provided from LINE developer's account you are watching right now. I think you will definitely enjoy the current status of HyperCLOVA. There is one more thing I want to tell you. LINE is a company that loves to open up and share. LINE is to publicize open source version of LINE language model in FY 2021. Of course, HyperCLOVA is not included. We want to achieve the better performance than existing open source language model and intend to upgrade periodically. So stay tuned for upcoming report. In this presentation, I talked about the latest information about LINE HyperCLOVA as well as large-scale general-purpose language model. As for large-scale general-purpose language model and prompting, I reported the following points referring to examples from dialogue system and QA such as, in some case, you get remarkably high quality, and there are many problems that cannot be solved ad hoc. At LINE, you can research and develop NLP, not restricted to HyperCLOVA, so I'm looking forward to challenging with you. Please wait for NLP-related information from LINE. That's all for my presentation. Thank you very much.